All right, we're going to go ahead and start 3.5 today, working with slopes and lines. Why do we learn this? You can use the graph of a line to describe your rate of change or speed when traveling. So finding the slope, remembering from last year in algebra, we have a formula for slope. Y2 minus y1 over x2 minus x1. Slope is always rise over run, so if you have a graph, you could count. If you have an ordered pair, you would use the formula. So let's go ahead and do one together, just to review from last year. So if it helps label those points, we have our x1, y1, x2, y2, 6 minus 3 over 8 minus 2, 3 over 4 gives you your slope. All right, if we were counting on a graph, 1, 2, 3 would be our rise. 1, 2, 3, 4, 5, 6 would be our run. Oh, I subtracted wrong. I'm like, what the heck? I divided by accident. All right, 3, 6. So then we get that rise over run. Make sure that we're always reducing our slope as well. All right, go ahead and find the slope of AB. You should get -2. If you don't, let me know. All right, if you are given a graph, we would just go ahead and count those. I know the points are kind of small, but always start with the bottom point. That helps because when you rise, it's always positive. And then if you turn to the right, it stays positive, but if you turn left, it's negative. Or look at the graphs. If it's going downward, it's going to be negative. Upward from left to right is positive. So up 1 over 5. Up 8 over -5 because we turned left. Fractions, you should leave them, but reduce them. Who remembers what a horizontal slope is? Think about this. Can you ski it? Yes. So it has a slope, but it is a 0 slope. Vertical. Can you ski it? Nope, not unless you're Spider-Man. So this is an undefined slope. If we were to put these in, the formula, we could go ahead and count -7, oops. Rise of 0 over -7, which reduces to 0. Where in this one, we have a rise of 9, but 0 can never be in the denominator, which is why it's undefined. You can always use UND as well as a abbreviation. All right, going up 2 and over 8. Make sure you're reducing. And then the last one, 4 over 4, reducing to get 1. And again, you can use the graph or you can use the formula, whatever works best for you. All right, so keep in mind, positive slope from left to right is upward, negative is down, 0 is the horizontal, and undefined is our vertical. All right, also recall from algebra last year, y equals mx plus b. It's a formula that you should have memorized and used a ton, where m is our slope, b is our y-intercept, and x and y are all the points that are on the line. Remember, this is a linear equation for straight lines. All right, 351. In a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. We learned that last year. Any two vertical lines are parallel. 352. In a coordinate plane, two non-vertical lines are perpendicular if their product is -1 of their slopes. We talked about it last year as opposite flips or opposite reciprocals. So maybe if you want to put an example in here, if our slope is 2 and our slope is 2, then they're parallel. If our slope is 2 and our slope is negative 1/2, then they're perpendicular, because these are flips and opposite signs. The biggest mistake you make is that you flip it, you forget to do the sign, or you do the sign and you forget to flip it. You have to do both parts for it to be perpendicular. All right, so we're going to take some of our stuff from last year and we're going to graph something, and then we're going to tell if it's parallel, perpendicular, or neither. This will kind of go into next chapter to prove quadrilaterals and triangles, like if lines are parallel, etc. How do you prove something's a square? Well, the lines have to be parallel, right? Okay, so we're going to go ahead and plot these. Over 2 up 1 is point A. Over 1 up 5 is B. Over 2 is C. Over 5 down negative 2 is D. All right, so determine whether these slopes of lines are parallel, perpendicular, or neither. I always say graph it first, because if you have like a trapezoid, obviously you may not have anything that could be parallel or perpendicular. Like if it doesn't even look like a right angle, don't test it. But when we go ahead and connect these, we get kind of a diamond shape or a parallelogram. So we're going to go ahead and find those slopes. You can go ahead and count. I'm going to change colors. So from D to A, we go up 3 over negative 3. So AD is negative 1. And up 3 over 3 for BC is also, I'll write the first in there, negative 3, which is negative 1. So we know that this line is parallel to that. Then we can check AB. Actually, let's change that to green so it doesn't get too crazy in our picture. All right, so up 4 over 1, which is negative 4, and then from D to C, up 4 over negative 1. So these are also parallel. So what do you learn? You know that all of these two are parallel, these two are parallel. If this was negative 1 and positive 1, we would know that it was a rectangle and that our corners were right angles. But negative 1 and negative 4 are not opposite flips, so those are not perpendicular. And then if none of our numbers were the same, we would say neither. So you did this last year, it's just now we're adding it into a shape. All right, let's go ahead and try this one. Let's go ahead and plot it. So we get negative 1, negative 4 is A, negative 2, 2 is B, 5, negative 1 is C. Now I didn't say anything about graph paper. I don't know if this is the first time we've used it this year, but note that you can go into Notability and pick a note that is graph paper. I also have graph paper scanned in resources, so you could always grab that as well. I feel like one of my points is not right. Negative 5, or 5, negative 1, 3, 4, 2, negative 2. Okay, they're all right. All right, so let's go ahead and try BD first. Rise 2, run 5, try AC, rise 3, 6, which is 1/2. Go ahead and try CD, 5, 2, 5, -2, and 6/1, and that's AB. Okay, so the only thing, we don't have any parallel lines because we don't have any that are the same number. Remember, it's important to reduce, otherwise we can't see them. But what do you notice about BD and CD? They are opposite flips, so that is a right angle right there. Okay? All right, why don't you go ahead and try this one on your own. And is that all we have left here? All right, so I have 4 more examples. So go ahead, pick 2 of them and do on your own, but you certainly don't have to do all of them. Pick 2 and make sure that you understand it. All right, this last problem for today, it says draw the quadrilateral and what type of quad is it? So this is kind of like giving us a little preview of what's gonna come. Must prove, not just assume, but graph first to see what shape you are trying to prove, okay? So we have 1, 4 is Q, 7, 8 is U, 9, 5, and 3, 1. Okay, so we certainly wouldn't try to prove that this is a square. Doesn't look like it, okay? Could be a rectangle. So let's go ahead and check our slopes. Rise of 3/2, so that's -3/2. Rise 3/2, same. So we know that these are parallel. Up 4, 6 reduces to 2/3. This is why it's important to reduce. And then up 4/6, which reduces. So these are also parallel, but what do you notice about the corners? Take a look at these 2 numbers. Good, they are opposite flips. So not only is this a parallelogram, but it also fixes the corners to be right. So it's a parallelogram. And it's a rectangle. Now, why is it not a square? Well, the lengths aren't the same. We can see that. You could totally do the distance formula and prove that false. It's not a rhombus. And trapezoids only have 1 pair of parallel lines. So this is kind of just a preview for next chapter. All right, math humor for today. How do the geometry teacher and the track coach wake up their son? It's time to rise and run. All right, awesome job, you guys.